Okay, in this video, we're going to go over a viewer request actually, and that is an absolute value, triple nested absolute value equation. And how do you solve that? So remember, an absolute value is simply the distance away from zero. So if you're 3 units away from zero, you can be on the negative side, positive side, that sort of thing. So whenever you start off with an absolute value equation, you try to isolate the absolute value itself, and you should always equal some kind of a positive number, because equaling a negative number doesn't make any sense, right? So in this equation here, we've basically set up a triple nested, an absolute value inside another absolute value inside a third absolute value, okay? And remember that when you start to solve an absolute value equation, you need the positive case and the negative case, and you basically just get rid of each of the absolute values in turn. All right, so let's start off with this particular absolute value. And we see that there's really nothing surrounding the absolute value itself, so we can get started in a positive and negative case. So here's my positive case on this side, and here's my negative case on this side. And I'm going to say, so I'm going to get rid of these two large absolute value brackets, and I'm going to say x minus 2 in absolute values minus 3 in absolute value, and then minus 1 is equal to the positive case, which is here. And notice that we got rid of the larger absolute value. And over here, I'm going to do the negative case. So I'm going to say the absolute value, again, of negative 2 inside the absolute value of minus 2 minus 3 minus the 1 is equal to the negative case. Okay, and now we're going to solve that. So let's just see what we get. So again, absolute value x minus 2 minus 3, add 1 to both sides, and then with a positive 4 over here, add the negative 1 to this side, x minus 2 minus 3, add 1 to this side, and I end up with a negative 2. Now remember our initial premise, the absolute value of any number must be equal to a positive number. In this case, it's equal to a negative number, so we cannot proceed any further here. So we stop right here, okay? Because a distance away from 0 cannot be a negative number. It doesn't make any sense. So let's continue on with this side over here. And we'll do the same thing that we just did up here. We're going to divide it into the positive case and the negative case. So again, let me just be clear how this works. Okay? And again, we get rid of the absolute value when we change it into the positive and negative cases. So over here, we're going to get rid of these two outer brackets, and we're going to say the absolute value of x minus 2 minus 3 will be equal to the positive case, in this case 4. Over here we don't have it. The negative case is going to be the absolute value of x minus 2 minus 3 is equal to the negative 4. Again, positive case, negative case. Sorry, I kind of squished that in there. Let's go ahead and isolate the absolute value. Add 3 to both sides. I end up with x minus 2, absolute value. It's going to add 3 to both sides. I'm going to end up with a positive 7. Over here, let's go ahead and add 3 to both sides. And I end up with absolute value of x minus 2 is equal to a negative 1. Again, this is an invalid statement. I can't actually use it, right? So I'm going to stop right there. And then I move to this over here. And I'll do it one more time. Let's get rid of the absolute value. Let's do the positive and negative cases. And now I have x minus 2 is equal to 7, the positive case, and then x minus 2 is equal to the negative case, or a negative 7. Now I can just go, these are both solvable, right? So I'm going to add 2 to both sides. X is equal to 9, or x is equal to a negative 5. If you were actually to put this equation into Desmos, you'll see that these are absolutely the correct solutions to this equation. Okay, so again, just briefly to go over it, remember that an absolute value is a positive distance away from 0, whether it's on the negative side or the positive side. So you break this up into two cases, the positive case and the negative case, and you get rid of the absolute value. We've done that, and each time where the absolute value is isolated, if it's negative, you cannot go any further, okay? And then you finally come down to your solution. Okay, I hope that was helpful.